Okay, so question number 6 is about Taylor-Loving parameters. And you've been given 3 graphs here. Sometimes hyperbolas and straight lines have no intersection. Sometimes hyperbolas and straight lines have 1 intersection, and sometimes they have 2. So this question is exploring maybe one of those conditions going to be met. So in part A, state the coordinates at the intersection between this and this. Okay, so I could set them equal to each other, or alternatively, I'd like to use simultaneous equations and go y equals this one, and the second equation is y equals x. Solve that for x and y, and the reason I like that is that it will give you as an answer in coordinate form the x value and the y value, and -1 in coordinate form is the answer. Because some students might have used a slider last year, we also accepted 1 decimal place in the second bit because they might have used the slider to get the answers. So when p equals 2, what we're now doing is we're replacing this number here with the letter p. If I replace this with the letter p, then I end up with this particular answer, which is going to be and of course I didn't put my little plus in between. So how about we try that again? And it's going to be -1 minus the square root of p and -1 minus the square root of p. And then the second is -1 plus the square root of p plus 1 and -1 plus the square root of p plus 1. And then of course state the value of p that has intersecting once. Well, this comes from the quadratic formula. So I'm going to look underneath the square root and see the p plus 1. And that p plus 1, when that equals 0, that's going to be the value of the discriminant equaling 0, therefore 1 solution. And p equals -1 will give you 1 solution. When p is bigger than -1, I can take the square root, and that will give me twice. And when p is less than -1, that's a negative square root, and that can never happen. So that's where that answer comes from. Now if I consider x and minus 2x plus p equals 4, I now get these answers. And what am I looking for? So obviously p being less than -9, p being greater than -9, and p being equal to -9 will give me my once, twice, and never. We have a situation in this particular occasion, however, so if I was to copy this, copy, and jump out into graphs and tables and edit, clear all that, and paste, and then X, and select, and look at this. When I have, so I better, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9, that's 10. I want minus, don't I? So I go to -9, 4, 5, 6, 7. So -8 is a situation where I have a horizontal line because we have some cancellation. So -8 also appears and also appears, but on my general solutions I didn't include -8 because it's a special case, and those who built a slider picked it up. We actually don't have a hyperbola and a straight line when x equals -8, because when x equals -8, the top can be cancelled too, and the x plus 4's cancel. So you end up with a horizontal, you'll have a line of y equals x and a line y equals -8. Does So that's A through to E.